Hi, I'm Jessie Garcia.
I'm Ariella Cohen.
And I'm Roberto Ramirez.
And we're Team Diamond.
This is our GUI, and the first thing you have to do is load your normal image. And you get to choose whatever you want. I'm going to choose the dog. And it uploads. And then you get to choose your hidden image. And I am going to choose hidden image number 1. And I am going to embed hidden image number 1 with red odd.
In order to understand how red odd works, we first need to understand how the flatten function and the expand function work. The flatten function takes the image that you want to hide and makes a logical array of all of the numbers that are to be greater than an arbitrary number, which is for us is going to be a 100. All numbers greater than 100 will be written down in the matrix as 1, and all numbers less than or equal to 100 will be written as 0. And then for the expand, it will take the hidden function matrix and expand it by creating 3 layers of all the same matrix and then combining it into one array. Now we know how expand and flatten work. We now find out how red odd works. First, you flatten the hidden image, which will then goes into values of 1s and 0s. And now you get the first layer of the array of the real image, which for now will be random numbers, odds and even numbers. And use odd check, which you put into a value of odd check, which is essentially first just use mod of the entire layer 1 of the real by 2. And if it's 1, it's an odd. If it's 0, it's an even. We use the real red layer, and we use the new odd check that we just found, and then you subtract that from the red layer, and thereby transforming all the red layer numbers into even numbers. And then with the flatten, then you turn the flattened image that you have into uint8 data, and add it to the new red layer. So just transforming all ones, if it's so that the number was odd in 1 in the hidden image, it will then become odd in the red layer, and if it was 0, then it would remain even. And then you put this to replace the real red layer with the new one that you just created, with the same blue and green layers.
Since we can upload up to 10 hidden images in the normal image, we're going to do another one. And this time I'm going to choose hidden image number 2. And I am going to embed it with the second red odd function.
So the second odd red embedding function works by inputting both the original image, which is the dog image, and the hidden image. The dog image is an RGB image consisting of 3 different matrices, each one representing red, green, or blue. So this method works by, for each corresponding pixel in the hidden image that is 1 is black in the hidden image, and each pixel that is 1 will make the second digit of the red array, which it's a number between 0 and 255. It will make the second digit odd if it's 1, or even if it's 0. So, for instance, if 140 and 1, so 140 needs to become odd, so this would become 5. And if this pixel here, it's odd, the second digit, but it's 0, so this would become even, which is 2.
Now we're going to embed another hidden image, and this time it's going to be number 3, and we're going to embed it with bit3 blue function.
So in the bit3 red function, we convert the original dog image into so that each pixel is an 8-bit form, so it's binary and it has 8 digits. So Whenever the corresponding pixel of the hidden image is 1 or black, the third digit of the binary becomes 1. Whenever the hidden image is 0, the third digit becomes 0. So if this were 1, this would become 0 if the hidden image was 0, corresponding pixel of the hidden is 0, and if this were 0, this would become 1 because the corresponding pixel of the hidden is 1.
I'm going to load hidden image number 4 with the bit for blue function. We're going to embed hidden image number 5 with the bit 3 red function. We're going to embed hidden image number 6 with the bit for red function. We're going to embed hidden image number 7 with the bit 3 green function. And we are going to embed hidden image number 8 with the bit 4 green function.
So we just embedded using multiple methods. We did the bit 3 red, blue, and green, and the bit 4 red, blue, and green. Now, how these functions work, I'll try explaining using the bit, try the bit 3 green. So for the bit 3 green function, we convert the original image so that each pixel is an 8-digit binary number, representing the number 0 to 55 just in binary. So in order to embed the hidden image in it, since the hidden image is only 1s and 0s, 1 digit of 1 and 0s, that is, if the hidden image pixel is 1, then the corresponding pixel for the green matrix C for the original image becomes 1. So this is the third digit, and it's going to become 1 now because the hidden image is also 1. If the corresponding pixel for the hidden image is 0, then the third bit becomes 0 as well. Alright, so since we're using these multiple functions, any function that's a bit 3 function, it does the same function where it changes the third bit depending on the hidden pixel for the red or blue depending on what it says in the title. The bit 4 function functions in the same way, except it changes the fourth bit. So, like, instead of the third bit here, it would be the fourth bit here.
Now we are going to upload hidden image number 9. And we are going to embed it with blue odd. And finally, we are going to load hidden image number 10. And we're going to embed it with second odd blue.
For blue odd, it is essentially the same as red odd, except instead of using the first layer of the real image, you instead use the third layer of the real image. Everything else applies the same way.
So the second odd blue function, it works exactly the same way as the second odd red function, except that we're using the blue matrix instead of the red matrix.
Now that we have embedded all 10 hidden images with a different method, we can save the embedded image, and you get to call it whatever you want. Now we want to recover the hidden images. We have to load the same embedded image that we had before. And here it is. And we are going to use recovery method red odd function, which displays hidden image 1.
And now, when we're using recover red odd, what happens now is that we take the encoded image and we use the mod hidden array, and 2 will then turn it into an array with 1s for odds and 0s for evens. And then we simply use the expand function to copy and paste this array into 3 layers, and then it displays it afterwards with 0s being black and 1s being white.
When we push second red odd recovery function, this is going to take a while.
It's a loop and it takes forever. But it works. It does work.
And there it is. There's hidden image number 2.
So on the second odd red recover function, first I created a 400 by 400 array of zeros, and each zero in a black and white image is white. So all you have to do is find where there should be ones in the black and white image. So I have a loop that goes through each pixel of the red array, and if the second digit is odd, as you can see in some of those digits that have been converted by the previous function, then the corresponding pixel of the hidden image becomes 1. If not, it remains 0 and nothing is done to them, and then this image is expanded into an RGB image and it becomes the recovered function, or recovered image.
With bit 3 blue, we get image 3. With bit 4 blue, we get hidden image number 4. With bit 3 red, we get hidden image number 5. With bit 4 red, we get hidden image number 6. With bit 3 green, we get image number 7. And then with bit 4 green, we get 8.
Alright, so for the recover function for the bit 3 green, I first made a 400 by 400 array of zeros, and so each zero will be represented by a white pixel in an RGB image. So it goes through the embedded image, and for each time it sees the third pixel of the bit as a 1, then it creates a 1 in the corresponding new array of zeros. So where there's a 1 becomes a 1. And this happens and it looks at the green array in order to do this. So then new array of 1s and 0s becomes the hidden image, which is expanded. The recovery for all the rest of the bits works the same way as for the bit 3 function, except using the different color arrays for the different colors mentioned, or using the 4th bit in the different color arrays for the bit 4 recovery functions.
With recovery method blue odd, we get hidden image number 9, and with second odd blue, which takes a while, we're going to get hidden image number 10.
Apologies for the length of this loop.
And there is hidden image number 10.
And for recover blue odd, it's essentially the same as recover red odd, except this time we take the third layer of the encoded image.
So the recovery of the second odd blue is the same thing as this recovery of second odd red, except it looks at the blue array instead of red array.